Similar to the arithmetic series, we will now discuss the geometric series. What's the difference between the arithmetic and the geometric series? The defining feature of the arithmetic series is that it must have a common difference. With the geometric series, the defining feature is that it must have a common ratio. Let me give you the simplest example of a geometric series. Every subsequent number is now bigger than the previous, not by a subtraction of 2 minus 1, 4 minus 2, and so on, but rather it's going to be 2 divided by 1. It's going to be 2. 4 divided by 2 is going to be 2, and what would have been here is going to be 8. 8 divided by 4 is going to be 2. So because we're going to have a 8 divided by 4, 4 divided by 2, and 2 divided by 1. 2, sorry. Because the ratios of all the successive terms and the previous terms are the same, we call this the common ratio. This is the defining feature of a geometric series. How will we find the sum for a geometric series of n terms? Let's consider the general form of a geometric series of first term a, but now instead of a common difference d, we now have a common ratio r. So a times a plus ar plus ar squared plus ar cubed, and so on. Where this is the first term, second term, third term, fourth term, and so on all the way to the nth term. To find a sort of closed form for the sum of a geometric series, what we're going to do is that we're going to take this same series, but instead of writing it forward and backwards, like what we did for the arithmetic series, what we're going to do now is multiply the entire series by r. So a times r is ar, but we have it in this second position. Ar times r is going to be ar squared, but we have it in the third position. And ar squared times r is going to be ar cubed, but we have it in the fourth position. And ar n minus 1 times r is going to be ar to the power n. So it's going to be, we're going to essentially shift the entire series to the right by one position. What we're going to do now is that we're going to vertically subtract 8 minus nothing. We're going to get a. Or rather, we should go Sn minus Rsn. Once again, a minus nothing is going to be a. Ar minus ar is going to be, they're going to kill each other. Ar squared minus ar squared, is going to knock each other off. Ar cubed minus ar cubed is going to knock each other off. Ar to the power n minus 1 minus ar to the power n minus 1 is also going to knock each other off. Now we're going to have essentially a blank space here, minus ar to the power n. All we're going to left with is nothing minus ar to the power n. So we're going to minus ar to the power n. Going over to that side, let's factor out the SNs. And let's factor out the a's on the right hand side. And let us isolate just the SNs. This over here is a closed form of the sum of a geometric series of n terms, with first term a, common ratio r. The first term of a geometric series, geometric progression, is 3 upon 11. So the first term of a geometric progression is given by 3 upon 11. And the fourth term is given by 24 on 11. The fourth term has 3 common ratios multiplied onto it. So we have AR cubed is equal to 24 on 11. Find the common ratio and the sum to 10 terms. Well, if this is term 1, and this is going to be term 4, all we can do is just substitute term 1, the A value, into this A. What do we have? So from T4, we're going to have AR cubed, but A is 3 upon 11 is equal to 24 on 11. The 11s cancel off, and the 3 cancels off with the 24 to become 8. So R cubed is equal to 8, meaning that R is going to be equal to 2. As for the sum to 10 terms, we know that A value is going to be 3 upon 11. We know that the common ratio is going to be 2. Let's really just plug it into the sum of a geometric series formula. Sum of 10 terms is going to be A 1 minus R 10 over 1 minus R. But what is A? 3 upon 11. 1 minus, what is the R value? 2. 1 minus 2. And lo and behold, all of this is going to be, well, not simplifying it, we're going to have 2 minus 1 is going to be minus 1. So the minus 1 and this would flip around to become 2 to the power of 10 minus 1. This is going to be the sum of 10 terms of this geometric series. The second and fifth terms of a geometric progression are 405 and minus 120. Find the seventh term and the sum of the first 7 terms. Once again, the second term and the fifth term of a geometric progression are, so the second term is going to be 405, and the fifth term is going to be minus 120. But what is the second term? In terms of A's and R's, is AR is equal to 405, and the fifth term is going to be AR4 minus 120. So from T2, we see that A is going to be 405, A is going to be 405 on R. Let's keep this here. And substituting the expression of A, which we derive from T2, into T5, we get 405 on R is going to be times R4 is equal to minus 120. So R4 divided by R is going to be R cubed, and minus 120, bring this 405 to the denominator, we're going to get minus 120 on 405, implying that R is going to be equal to minus 2/3. If the common ratio is 2/3, minus 2/3, what then is the A value? Well, there's going to be 405 divided by minus 2/3, and the A value is going to be minus 1215 all over 2. Now, what is the seventh term? The seventh term of a geometric series is given by AR6. Hence, A is going to be minus 1215 over 2 and minus 2 on 3 to the power of 6. And what we're going to get is that term number 7 is going to be minus 160 on 3. And what about the sum of the first 7 terms? We're going to get the sum of the first 7 terms is going to be a, the a value, 1 minus the common ratio to the power of 7, and divided by 1 minus the common ratio value. And if we were to plug this out into the calculator, we're going to get S7 is going to be equal to minus 2315 all over 6. A geometric progression is the first term 16 and the common ratio 3 and 4. If the sum of the first n terms is greater than 60, find the least possible value of n. Once again, a geometric progression has the first term 16 and the common ratio of 3/4. If the sum of the first n terms is greater than 60, so if the sum of the first n terms is greater than 60, find the least value of n. What do we do? Well, we need the sum of the first n terms to be greater than 60. Let's change color. So the sum of the first n terms has got to be greater than 60. That being the case, what are the sum of the first n terms? A 1 minus r to the power n over 1 minus r greater than 60. But what is the a value and what's the r value? A is going to be 16 1 minus 3/4 is going to be 1/4. We're going to get 16 1 minus 3/4 to the power n is greater than 15. Because now we have the unknown, the number of terms, the n value being a power, we need to solve for the power. For that, we're going to invoke the use of logarithms. To bring the power down, we just simply log both sides. Oh, whoops, this was meant to be a greater than. And if we were to, this fraction is going to be 9.637, but because the number of terms has got to be a positive integer, we simply just round up. So we need 10 terms for the sum of this series to exceed 60.